U substitution is such a powerful integration technique in calculus, but a lot of the students I tutor struggle to realize when you can and can't use U substitution. And so what I want to do here is walk through this example and hopefully show you some of the intuition behind it. We have an expression that has cosine inside of an exponential. And typically you want to look at that innermost function and ask yourself, do I see the derivative of this innermost function in the original question? And if I don't see the exact derivative, do I at least see the derivative in the same family? So remember, the derivative of cosine is negative sine, but really we're just asking, do we see something like a sine in the original question? The negative, okay, it's not exact, but it's close enough. And we do see that. So that gives us a lot of confidence that we can choose u to be cosine of x. So let's go ahead and do that. We'll take the derivative of u with respect to x, which of course is negative sine of x. Remember, we didn't want that negative, so we can take the negative sign and move it to the left, and we can take the dx and move it to the right. And so we're left with negative du equals sine of x dx. Sine of x dx is great because it's what's in the original question. So we can replace that with negative du, and of course we can do our original substitution, which is cosine of x equals u. Now we can rewrite the equation to be negative 8 times the integral of e to the u du. All we've done is rewrite the question. Now we need to solve the question by finding the antiderivative of e to the u, which in this case is just e to the u, right? It's an easy one. So we get negative 8 e to the u plus c. We'll undo that substitution, plug back in cosine of x for u, and that's our final answer. Now, a lot of you will have seen this immediately, right? That you could use u equals cosine of x because sine is in the equation. But for those of you who didn't see it immediately, I encourage you to just list out the different functions present in your original integral. So we had the exponential, we had cosine, we had sine. And then just ask yourself, which two functions are related via the derivative? So obviously, sine is in the family of the derivative of cosine. Let's say we had the integral of x cubed, and we also had some x squared, right? You would notice that x squared is in the family of the derivative of x cubed, despite not being exactly equal to the derivative. That's a really good technique to identify u sub.